This is 29 pounds of raw ARM horsepower. ARM on the desktop. At least if you're a power user, is here. What's the dealio, Thelio? I don't know, let's take a look. A System 76, if you're not familiar with them, I like their mission a lot. They're all about open source and building hardware. It makes some pretty nice looking machines as well. In a lot of my videos, I use the System 76 launch keyboard that I bought myself because I just like it and it's programmable and a lot of fun. And so I've borrowed this machine from System 76. Greetings from Thelio. Greetings from Thelio. Greetings from System 76. Thanks for joining us on a mission. Here's the support. Nice. Unleash your potential. Got some stickers, some fun goodies. Ooh, Desktop Sentinel, Melvin. Now that is a super compact machine considering you can have 128 cores, 512 gigabytes of memory, a terabyte of memory, and beyond. At the rear we can see we've got 3 DisplayPort, 1 HDMI, a little nub Wi-Fi antennas, power input, and not a lot else, but it is a standard ATX layout, and we can see that we've got a server motherboard, dual 10 gig, plus out-of-band management in a separate port, plus 4 5 gigabit USB ports. Let's pop the side and see what we got going on inside. Neat. Now, if you're wondering about the power switch, it's pogo pins. There's little pogo pins in there. And there are some punch outs for front panel type connections on the top of the case, depending on what options you get. And the red accent on the front, which is Ampere, is also replaceable if you prefer wood grain or something a lot of fun like that. The ASRock Rack Ultra D8UD1L2T. We also got an Asus GeForce RTX card of some description in here, so that'll be a lot of fun. It's like, hey, guess what? It works with ARM. This ARM motherboard, if you notice the motherboard layout diagram here from ASRock's website, it doesn't have the standard 24-pin power connector. That's okay. It comes with an adapter. So just for the cables that it needs. This motherboard uses 12 volt natively. This is kind of important in data center stuff and data center scale. There are a lot of data centers out there that are running on DC only, well, like 440 volts DC, or have other things that they have done to be more power efficient. And historically, ARM has been, a top shelf product for performance per watt, performance compute. Maybe not the absolute fastest per core, but in terms of unit compute per dollar, unit compute per watt, definitely leaders. And so that kind of makes sense that, let's try to do a motherboard design that's like this. You also see this with AMD EPYC motherboards, where there's some ASRock motherboards that are 12 volt input only, and you only have the little control cable for your 24-pin standard ATX power supply, if that's the kind of power supply that you're going to run. This design uses an Arctic cooler, which is awesome because Arctic has always been really good to the builds that I've put together. And we can see that we've got a fresh air intake baffle from the side. And this is all metal construction. They've also brought out a few extra fan headers. Should you need to run more fans on the side, all the hookups are here for that. You can also see our primary SSD is the KC3000 from Kingston. It's perfectly good Workstation class SSD. ADATA XPG reactor power supply and another Be Quiet fan in the bottom. I can see that the rear exhaust fan is also from Be Quiet. So interesting choice. Interesting choices of hardware here. Let's hook this up and see what we got going on. Out of the box experience is pretty good. Shipping with this Ubuntu 24.04 LTS because they figure you're going to be doing developer stuff, and Ubuntu is probably more interesting to you than Pop! OS. There may be some cross-platform stuff between Pop! OS for ARM and Ubuntu for ARM, but Ubuntu 24.04 LTS for ARM is a first-class citizen, the port from x86 servers and everything else to ARM. And so we can see we've got 128 Neoverse N1 cores in this. So this is the 128 core Ultra configuration, which is amazing, from Ampere, and 512 gigabytes of memory. And we can see that CPU fetch and Neo fetch work as they should, which is exciting. Now let's talk for a second about the build quality and special bells and whistles on this case. before we get into the benchmarks. This is a really fun case, and System76 did start selling these separately. They do some really creative things to manufacture them here in the US, and everything is folded or stamped metal, which is great, and everything is put together with screws, not rivets, which is also great. And that also makes for a lot of modularity and configuration. But not just the case, there's also little widgets to deal with the fans and LEDs and everything else. Printed circuit boards that distribute fan control and will read from the fan headers, and the button interface with the pogo pins and other things like that. So if you check here on this side, there's a PCB with a microcontroller that's doing some heavy lifting to improve quality of life when you use this case with your motherboard, so that you can have more distributed fan control. A lot of the time on these server motherboards, they're configured to make sure that the fans scream all the time, and that is not necessarily what you want in a more desktop/workstation configuration. I mean, sure, you can do temperature monitoring, and this board can read what the motherboard is requesting off of a fan header, but this can also be dealt with in a little bit more of a controlled fashion, as opposed to just run the fans at 100%. Out-of-band management on this does also let you control the fan headers and everything else like that on this ASRock motherboard. So the ASRock out-of-band management we'll talk a little bit about in a second. But there's a lot of hardware engineering here that is easy to look over because it is well implemented for what it does. I'm slightly surprised there are no front panel or auxiliary USB or USB Type-C. The motherboard does actually have an extra USB header, but it's not routed to the back or the front or anywhere else. It's also a little bit in the way of the GPU. At the end of the day, this ARM motherboard is technically a micro ATX motherboard, and so that's why they've put the GPU in the bottom. And you do have one X16 PCIe slot that is free, so you can add another single slot peripheral, or pop your Wi-Fi card out and use another 2-slot peripheral. The Ampere platform is a DDR4 platform, and so DDR4 memory is fairly inexpensive. It's registered error correcting DDR4, so if you're worried about ECC, yes, it's full implementation of ECC, and you can run EDAC utils and RAS daemon and get that sort of info, no problem. In the build, there's also a lot of fun little details, like there's some meaning in the arrangement of the planets on the back of the case. You can see there's little rocket ships stamped out of the metal here and there. A lot of fun, cool details. This bracket for holding the GPU is very sturdy, so these things are very ship-worthy, or if you travel to trade shows, things like that with these machines. These features help prevent the machine from breaking itself. Also, physical mechanical support for the heatsink, so you've seen some of those get bent in shipping sometimes. It's well supported here. Even the power supply has an extra bracket to hold it down sort of at the mid plane, which is very nice. Our cable management is also very nicely done. A lot of tie-offs and Velcro straps and screw holes and a lot of options depending on how this configuration of your workstation might change over the years. So it's very nice to see that in the build quality. It's very nice to see that they've done such a good job with the cable management and cable routing and everything else. A big part of what you're buying from System76 is that sort of thoughtfulness and aftermarket support and everything else. I mean, sure, you can, get an ARM bundle and build a machine yourself, or you can just buy this machine and be ready to go on day one. I think it's an interesting choice that they chose NVIDIA for the GPU. I mean, you of course can configure your machine however you like, but NVIDIA and ARM, they've got a lot going on. They're cooking up a lot. And an ARM-based CPU is certainly the CPU of choice for NVIDIA in their own giant, in everything from B200. I mean, Grace Blackwell, yeah. Now, what about features like IOMMU and PCI Express pass-through? What about support for that on this platform? Fantastic news. It's basically been a first-class experience. So, for example, if you're a driver developer, I've passed through the AX210 Intel adapter. It's a PCI Express wireless device. You can see the antenna sticking out the back here. I pass it through to the virtual machine as a PCIe device, and it shows up as a network controller. And if you go to Intel's webpage and if you download the drivers, it'll mysteriously not install. But that's because this is an ARM64 platform. It says 64-bit on Intel's website, but they mean x86 64-bit. So if you were a developer working to develop ARM native drivers for a piece of hardware, this is a godsend because you have all of these PCIe slots to work with. Things like bifurcation can work fine. If you're doing higher end development, this is an NVIDIA A30X. This is basically a GPU on a dual port 100 gigabit NIC. This thing is insane. It is just absolutely bananas. But if you're doing, say, software-defined networking, you want to build a new hardware stack for something, you need to test something on Linux, Windows, different platforms. Again, PCI Express pass-through, SR-IOV, you get into SR-IOV stuff. I did not fully test SR-IOV, but it looks like it's going to work. If that's really exciting for you, hit me up in the forum. Let me know what your project is, because just because it works with SR-IOV with some of my devices doesn't necessarily mean that it's going to work in all scenarios. However, because NVIDIA and ARM have done a lot of work together, I'm pretty sure that the InfiniBand aspects of it and the SR-IOV aspects of it from that side of things are going to work fine. It's just if you want to go off-label and get creative with other stuff, maybe SR-IOV needs a little bit more polish. But for PCI Express pass-through, running multiple GPUs, passing through a GPU to a Windows host, which there's a couple of gotchas there with the resize bar and base address stuff on that side of things. But this is a good platform for working out those issues if you're a developer on ARM working with it. I was delighted that I could pass through PCI Express devices as easily as I have, just clicking a few things, setting up the VFIO PCI driver to grab those devices to prevent the host machine from doing it. And then we're off to the races. This setup is also really easy to provide remote access. So if you wanted to run a couple of virtual machines with a couple of PCIe devices that your developer team was debugging, then you can set that up. I've sort of qualified that. That's in the how-to. Like you can run through the how-to, the ARM setup, Windows virtual machines. Like this virtual machine gets this device. This virtual machine gets this device. This virtual machine gets this device. Heck, maybe you could even go crazy and add a whole bunch of X4 PCIe devices with breakout cables. Doesn't that sound like fun? Sounds like a job for another day, though. I just love the ridiculousness of this much GPU compute, 24 gigs of HBM on a network card, because that means you can offload a lot of stuff to your network card, and that works fantastic. So, neat. So there's a lot of people that are really excited about ARM, and ARM has a tremendous amount of potential, and I'm kind of giddy seeing it here on my desk in such a cute little package that is ready to go and has this level of polish. Let's get to the benchmarks. So yeah, the benchmarks for this look pretty solid. I mean, this is the fastest ARM desktop you can get, but also the developer experience. Like, this was also the least headache ARM experience. Did you know that the Snapdragon ARM development platform that was originally going to be released was recalled? Like, it released, some people got them about 1,000, and then they deleted the HDMI port, and it turned into a huge debacle. Even if you have an ARM-based Windows laptop, it is an extremely unfun developer experience, still to this day. And the thing that melts my brain is that Qualcomm is letting OEMs manage the video drivers. Do you remember when NVIDIA let board partners manage the video drivers? That was a dark time in video drivers and a dark time for consumer experience. It's almost like we've learned nothing. Whereas this platform, because it's PCI Express, you can do what you want. Do you want to run an AMD GPU in this? Yes, you can. Do you want to run an NVIDIA GPU in this? Yes, you can. And I get it. I get why they shipped this machine with a 4060 Ti. It's because NVIDIA has done a lot of work to be up and running on the ARM platform, including downloadable Windows drivers for the 4060 Ti and other modern NVIDIA graphics cards, which is actually pretty exciting. And that brings me to the next thing, which, as far as I know, there's not really a good guide out there for getting Windows up and running with QEMU as a virtual machine, but that's exactly what I've done here. So I've written a guide on the Level 1 forums, and let me just really walk you through it, because it was surprisingly buggy and full of a lot of non-obvious things. The first is that when you get QEMU installed in Ubuntu the usual way, and you got all that set up, and you go to create the virtual machine, the wizard literally cannot create a virtual machine or the GUI. I mean, you can do it from the command line, but it's fine. The Virt Manager interface will error if you just next through and just try to create a virtual machine, because it's trying to use Hyper-V enlightenments on this platform. It doesn't support Hyper-V. So the first thing that you have to do is go into the menu and tell it that you need to be able to edit the XML so that you can tweak the XML that's generated by the GUI when you go through the virtual machine creation process. It also helps if you've pre-downloaded the Windows 11 for ARM ISO, and it also helps if you've pre-downloaded the VirtIO ISO from Red Hat because you need the ARM64 drivers because the Windows drivers don't have anything. And this is a problem that you'd run into even if you're planning on running Linux for ARM as a virtual machine, because it tries to use those Hyper-V enlightenments or the Hyper-V extensions, which are not a thing for this. It's like, oh, relaxed Hyper-V. This is ARM. This is Neoverse N1. What are you doing? Are you drunk? It's crazy. The other thing that I'll complain about is the Virt Manager GUI. When you tell it that you want more than one CPU, it literally does more than one CPU by socket. This should be done by core. Most modern operating systems are not designed to deal with more than 2 or 4 cores. So it's like, I would like 16 CPUs. And it says, all right, this machine has 16 sockets. So on Windows, for example, it'll deal with 1 or 2 sockets, and then it'll ignore all of the other CPUs. So when you add 16 cores and then you go in the Windows Task Manager and you only see 2, you have that trap that has been laid for you to thank for that. Fortunately, in the guide, it sort of walks you through not doing it that way. Now, 16 cores and 32 gigs of memory is what I've passed through from our 512 gigabytes of memory and our 128 cores on the host, and the performance loss overhead is quite good. It's within a few percentage points. We can see in our Cinebench R24 scores here that our single core speed is roughly in line with bare metal. If you want to run Windows on bare metal on this thing, the state of that is actually pretty straightforward to do in 2025. So you could create a Windows ISO and dual boot Windows. But if you're doing driver development or native ARM development, I think running Windows virtual machines or even multiple Windows virtual machines on the ARM platform is a much more straightforward way to do it. See, the thing that you got to keep in mind is that ARM is literally everywhere. Embedded, automotive, internal systems development, HVAC, pretty much anywhere where you can save a few bucks. You don't need the fastest core that you can possibly get, but you're still doing some pretty heavy lifting. The PCIe interface, the networking interface, well, these are all standards, and Ampere has built their CPU to adhere to as many of those standards as possible. Heck, even if we check in Linux, it says that it does support suspend to RAM. Suspend to RAM was a little dangerous in my opinion. It's like putting the workstation to sleep, waking it up. That's not even something that works consistently awesomely on the WRX90 Threadripper platform. You really have to dot your I's and cross your T's to get a good suspend resume experience on the Threadripper Workstation platform because of various related and unrelated reasons. There's multiple layers to that onion. So this does it a little better, and that tells me that Ampere has tried to put work into making their server CPUs a little bit more accessible from a workstation standpoint. There's a lot of people out there that want to put their machine to sleep when they're not sitting at it, which I get it. That makes sense. Now you might notice my Windows virtual machine here, I'm running Steam in the background because Windows will let you run x86 binaries, but also there is a beta, supposedly, a Steam client for ARM. I'm not sure which one it installed. I just went to the website and downloaded the thing. I'm pretty sure this is just running an x86 binary in emulation. If you are booting this on bare metal and you have the NVIDIA driver installed for the GPU, that works. You can do GPU accelerated gaming or whatever you want to do on this platform. That's no problem. It's a fun adventure. It's not a problem, but it is a fun adventure. I'll leave it at that. Now for Windows 11 on bare metal, you will need a hardware TPM module to make Windows 11 happy. Fortunately, System76 can ship you one, or you can pick up one on Newegg or from the internet for 20, 30 bucks. It goes on a header on the motherboard and that's pretty much it. And how insane is it? It's like System76 running Windows on this hardware. But again, if you're a developer and you're doing multi-platform ARM development, this is great. This is fantastic. Now, the light bulbs might be going off. What about Android? And what about using Android for this platform? Well, that's a little bit of an engagement challenge. If you'd like to see me set up some emulation for Android or phones or something like that, this is a little outside my wheelhouse. Hit me up in the forum. Let's discuss. Let's discuss what your needs are as a developer and if this platform could be useful for native ARM Android development, or if you want to do Android emulation on a platform like this and how that might run. Because Android ARM emulation on Windows, not great, and running Android on x86, also not great. So this might open up some possibilities because this has been a dream developer experience. System76 has done a really amazing job putting the hardware together, and the software stack here is first class-ish in 2025. Like, I'm surprised how good of a developer experience this is. This is a perfectly reasonable developer workstation. And just the fact that I've got 128 3 gigahertz Neoverse N1 cores at my disposal is pretty amazing. So what is there not to love? Well, I would love more USB ports. I would love front USB, but I get it. You can take matters into your own hands and add more USB at the rear, even without using your USB ports, using the header on the motherboard. But overall, this is a top-notch system from System76. System76 prides themselves on delivering a first-class Linux experience, and this is certainly a first-class Linux experience. And if you have to do ARM development as part of your job, this is really one of the best out-of-the-box options that you can get, if not the best. I mean, as configured, this is the fastest ARM system you can get. This configuration from System76 is about $7,200, $7,300 at the time that I'm doing this video. They, of course, have other configurations that are a little bit less. Spec for spec, it is a little cheaper than a Threadripper workstation, but core for core, those Threadripper x86 cores are going to be a little faster, or your Xeon x86 cores are going to be a little faster per core. DDR5 platform, newer platform. Alternative platforms, PCIe Gen 5, DDR5 will have newer features. The cores will be a little faster. Ampere first announced the CPU that's in this in late 2021, as I said, so it just depends on what you're doing. Horses for courses, I suppose. Bottom line, if you need to develop on ARM in a whole bunch of different scenarios, this is your best option that is going to waste the least amount of your time. And I like that. We also know that Linus Torvalds, creator of the Linux kernel, is hard in the ARM ecosystem, and he really likes what Ampere has been doing, and so this is a first-class Linux kernel experience. Linus is doing a lot of Linux kernel development on an ARM system similar to this one, very, very similar to this one. And so that kind of makes this a first-class citizen in terms of Linux kernel and ARM development, things like that. What goes unstated a lot of the time is that the reason for that is that over the years, the Linux kernel has accumulated more and more cruft dealing with hardware quirks and hardware idiosyncrasies and bolting features on and things like that. And this is true in the x86 ecosystem, whether it is Intel or whether it is AMD. And so Intel and AMD sort of, as part of recognizing that problem and some other problems in the x86 ecosystem, AMD and Intel have joined forces. They've come together to form an x86 committee to try to right some of the wrongs of the past. Meanwhile, ARM's approach to forward compatibility, backward compatibility, hardware architecture, fixed length instructions, sort of kind of, has historically had a lot more forward thinking, or if you want to describe it another way, a lot less baggage from past technical debt to bring with it into the future. And certainly Apple, Apple switching from x86 to ARM, that has benefited Apple tremendously, and they're pushing ARM as far as it can be pushed, and they have machines that have tremendous performance with relatively low power utilization. And this is the first system where I've really felt like ARM on the desktop could be rapidly approaching, because for most people, especially doing development on ARM platforms, like I say, and as a day-to-day workstation, this thing has a ridiculous amount of horsepower and it gets the job done. So I could see that folks that are frustrated with x86, whether in terms of feature creep or feature misparity or, too many features for what they need or overcomplication, would prefer a simpler platform that is also more consistent. Keep in mind, all 128 cores here run at 3 gigahertz. This doesn't have turbo boost and things like that. And some system architects do not like inconsistent software performance. And so this is an incredibly attractive platform. It's designed for the cloud and servers and things where all 128 cores are going to be loaded all the time. But this is what we have for the Ampere M128 Max 3.0 CPU. And yeah, it's a great experience. So that's been a quick look at this system and the first round of benchmarks that I was able to do on it. But hey, if you want to see me test a workload or take something else for a spin, hit me up at the forum. I'm signing out, and I'll see you there.